In concrete waterproofing, membranes are applied to external or internal surfaces to form a barrier that prevents water from penetrating. The application of waterproofing membranes is labour-intensive, requires skilled applicators, and is therefore often destined to fail. Poor workmanship alone accounts for 90% of all waterproofing membrane failures. Choosing the wrong membrane for the intended application or substrate can lead to the failure of the waterproofing application. Incompatibility of the selected membrane with other products such as primers can lead to debonding of the membrane and failure of the waterproofing. Debonding of the waterproofing membrane will allow water migration between the membrane layer and the surface, and ultimately into the concrete. For membranes to be considered for underground waterproofing applications, international standards require the membrane to be fully adhered to the substrate. Many membranes, such as EPDM, PVC or TPO membranes, are mechanically bonded to the concrete surface and thus are not recommended for below-grade applications. Debonding can be caused by a number of factors, including application to an uneven surface, application to a damp or wet surface, application to a contaminated surface, lack of priming or insufficient priming of the surface prior to installation of the waterproofing membrane can lead to debonding. Insufficient coverage or uneven application of a liquid membrane prevents establishing a uniform thickness of the waterproofing layer. This can result in the failure of the application, as thinner parts of the membrane get damaged quicker. Not fully bonding overlaps pose potential breach of the waterproofing layer. Membranes that come apart at the seams allow water to migrate through and penetrate the concrete. Blistering is caused by insufficient priming of the surface. As a result, entrapped air builds up under the membrane, causing debonding and formation of blisters on the surface. These blisters are prone to puncture and then result in a breach of the waterproofing layer, allowing water to pass through and penetrate the concrete. Waterproofing membranes are exposed to a high risk of damage. Often, this damage occurs in the subsequent stages of the construction schedule. Puncturing often occurs, for example through concrete drilling, backfilling and pipe installation works. Tearing of the membrane usually is the result of building settlement, building movement or expansion joints. Both puncturing and tearing represent a breach of the waterproofing layer and thus a failure. Many waterproofing membranes deteriorate over time due to exposure to UV rays, harsh environments, aggressive groundwater or permanent ponding, leading to the disintegration of the waterproofing layer and thus the failure of the membrane. In conclusion, membranes are not recommended when an efficient and long-lasting waterproofing solution is required. Newer technologies that permanently reduce permeability and improve concrete properties and durability can be employed without the occurrence of problems commonly associated with membrane applications.